slide. These two individuals are fantastic disruptors, and use of the term disruptor in absolutely the right way in what we do. So I'd like to introduce Dr. Petra and Emma Mailey from AtkinsRéalis, who are going to take us on a journey through data-driven geosciences. Thank you.
Morning, everyone. So as Martin said, myself, Petra and Emma Mailey, we work for AtkinsRéalis. I work there as a hydrogeologist, but I've come from the chemistry and microbiology background and did a PhD in bioremediation of groundwater. And when I started my job, I was working with a lot of data, and I was working with it in spreadsheets, and I was basically getting bored. So I decided that it'd be a good idea to automate my own job and therefore learn to program in Python. And ever since then, I've been working in digital innovation and data management and that area.
Yeah, so I'm a geologist, engineering geologist, and I like geology data, but I also like spatial data. So I have got training in data science. But the reason we wanted to do this talk is that as part of this digital geoscience conference, I think it's really important that we talk about data, because that's the building blocks of basically technology, digital, everything we're going to do. So thought we'd give it some information first.
Yeah, so we're going to cover three topics during our talk. We're going to firstly talk about importance of data science in geoscience. Then we're going to look at the current state of data science in industry, and then we're going to look to the future. What can we do to make things better in this area? So we'll give you a few definitions to start with, to make sure we're on the same page when we're talking about data science and the industry. So on the screen, on the left-hand side, you can see a quote from the Amazon Web Services, and it talks about data science, and data science looks at large amounts of data and uses multidisciplinary approach to then come up with meaningful insights. So as Rusha said, you can't just have data, you need to come up with something that then helps you with your decisions or whatever you're doing. And the Venn diagram I find particularly helpful because it shows you what skills you need to be a data scientist. So there are some skills in computer programming, statistics, and domain expertise. And the domain expertise in here is key. Because if you only just have the programming skills and the statistics skills, you don't really understand why you're analyzing the data, what you're trying to achieve. So the domain expertise is really important. But at the same time, if you just have the domain expertise and perhaps don't have some of the additional skills that apply to data science, you might be limiting yourself in what you can with the data and what conclusions you can draw from that. And we've provided our own definition of the geoscience industry. So we are consultants. Emma works in the geotechnical space. I work in the geo-environmental space, but we're also considering contracting, and we work within the construction industry. So when we say the geoscience industry, this is what we mean, because we are aware that there are other fields of geoscience. So how can data science support geoscience? Why is it important that we've got the data science skills? So I went on to the BGS GeoIndex, and I downloaded the locations of all the boreholes for which the BGS has got the logs. Granted, these are logs that are mostly PDF scans or images. And you can see that pretty much when you plot it in GIS, it just covers the country. It looks quite impressive. So imagine the potential if we had that data in some format that we could actually tap into it. So our industry tends to look at sites, at individual sites, one site at a time, and interpret the data for that site. But what if we collate all that data across all the sites? We could start gaining new insights. There's also a quote from the Geospatial Commission blog, and which states that about 500,000 boreholes are drilled in the UK every year. That's a lot of boreholes. And if we just had access to that, we could do so much with it. And I've got a little prompt of the carbon image. Even just reducing the amount of ground investigation we do would have impact on the carbon that we're producing as the industry. So it would have a great impact. And another one, there's an example of a correlation that's been used in the industry since the 1970s. And look at the number of data points that are being used for it. We could have so many more data points if we just used all that data that we're collecting. So the key important thing for working with data science skills is to manage the data, and that's why it's in bold on that slide. So the benefit is we could manage, analyze, and interpret the large data sets, and we could apply the machine learning to it. We could start predicting ground conditions. There's no limitations to what we could do with that data. And if you've got data science skills, you start thinking differently, you start working differently, you work out like different workflows, what you can do, how can you work in the industry. It can potentially increase efficiency, and it definitely can lead to improved collaboration, and we're going to cover it during one of the case studies that we're presenting.
So kind of wanted to do a bit of an overview about where are we now sort of in the industry, like what we're kind of looking at. So we all have raised expectations. I bet everyone here has a smartphone. So if you're used to instant web access, you've got a smartphone, you might have had Netflix tell you what films that you want to watch, or Spotify. So why wouldn't you, when you get into industry, have sort of those expectations as well? So the apps and the technology that are based on all work on data that's well structured and managed effectively. And around 4 in 10 adults working a professional occupation report AA could make their job easier, which probably me included in that. So what does data that we use look like now? So we've got unstructured data versus structured and semi-structured data. So unstructured data doesn't have a predefined data model, so it can't necessarily be utilized as efficiently without knowledge of data science to apply like text mining, etc. It's stored in something like a data lake, things like Excel that we all might absolutely love, but it's not necessarily a database. It can be a bit messy. So we've got semi-structured data, which is a lot more if we're going to do anything to do with analysis. We like semi-structured data, like JSON files, CSVs, XML. Now, this doesn't have predefined data models, but it can be searched and analyzed better using metadata, and it does require a lot of processing. And then you have the structured data, which is easily decipherable by machine learning algorithms. It's data that's stored in relational database like SQL. So typically, we're not in the realm of properly utilizing this type of data. And if we are, it's usually converted from something that's semi-structured. So in terms of how we use and have the data flow of what we're using, so we've got at the end, we've got data creation. This is data preparing, cleaning and wrangling, and then we might store that data. That could be short-term in the form of a local database in a CDA, or hosted on the cloud in a folder or on a USB stick, still data storage. Data is shared and actively used. So we're doing analysis, we're scrutinizing it, we're preparing it, and we're sharing between parties. And archive retention. So that would be after the initial purpose is finished, then we start there, then deletion. So if data's become obsolete, it's no longer being useful. But between the cycle, other steps can go in and out. So this flow is more interesting when we add different users into it. So if you've got clients, contractors, clients, people going back and forth, it might stop at some point, because if someone has created some certain data that can't be used elsewhere in the chain, it stagnates. And that's why your money's lost. So our favorite, as if you're an engineering, a geologist or a geotechnical engineer or geoenvironmental, you know about AGS data. So is this standardized? Not really. Right. So AGS data is the most commonly used data format in like geoengineering. It's a data transfer format. that's used by geo professionals. And recently AGSI was introduced to handle ground models and interpretive data, and it's a semi-structured data. So it appears from first glance to be standardized, but it's not a storage format. It's actually a transfer format, and it requires specialist software like OpenGround or GINT to be utilized effectively. It's not necessarily a standard, so it doesn't have a standard schema. You can add columns, put things in, change geology codes as per. So in terms of data infrastructure, we're talking about like hardware, software, networking technologies that are used to support the storage, processing, and management of data. This can include databases, warehouses, lakes, all kinds of places to store the data. So you might see that I've got an example of a common data environment up on screen. So that would be where there is a single source of truth, where lots of people can access the data, and there's only one version of it, which is version controlled. Some examples that you might be actually quite used to using are CDs of SharePoint. You might use OpenGround, Autodesk Construction Cloud, ProjectWise, GINT, etc. But actually, more likely, I think we all store our data in File Explorer or files or USBs we might be guilty of. And that can lead to duplication. And it's not the most efficient way to store your data or manage it. And exactly, data management is key, and data storage is data management. So in terms of our data science skill set and mindset, where would we be in our industry? So we might come into the industry from now that the perception would be that fresh entrants into the industry are more likely to embrace new technology and new ways of working, but they might not necessarily know about the data that we use, like AGS, because it might not necessarily be taught in university, but they might have experience in programming and analysis, and there might be some GIS. If you've been in a little bit longer, you might be used to using this type of data, so you more likely to be learning on the job or self-taught. And whereas people who've been a little bit longer might not be as receptive to change, but have the domain expertise, but might be underutilizing their capabilities. So we kind of like go back to the Venn diagram that Petra mentioned, where we've got the computer programming skills and the domain expertise, and it's kind of, we want more well-rounded people in terms of the Venn diagram.
So what can we do to improve things in the data-driven geoscience? We're going to look a bit into the future. What can we do? Well, everybody can do. I've got this big green blob on the screen, and I often find that people think that they're going to have a digital tool that's going to do something for them. They're going to give it a spreadsheet that's all coloured and with merged cells and so on, and then they're going to force it on this tool, and it's going to give them an answer. And I'd like to say, don't think about digital tools, think about different ways of working. Can I do this differently? Can I have a different workflow? Can I store the data in a better way? Can I have that in the database? And think about data management. How are we storing and managing the data? So using the common data environments and ideally a database. If you can, embrace new skills. Learn on the job if needed. You can access some free online training. There's just examples. I've done courses on Codecademy. There's courses on LinkedIn. There's lots of other stuff available out there. Lead by example. If you're leading a project and a delivery of it, think about how can you do things differently. Use people's different skills. You can engage in mentoring, and this is not only a more senior person mentoring somebody more junior, but it actually can be the reverse mentoring, which I think is quite good for data science skills. And try to influence your employer organization. And we're going to dive into what different organizations could do, and you as individuals within them. So if you work for a commercial organization, I'd suggest you promote and empower individuals that embrace change. I often find that having data science skills might not be necessarily part of how people are assessed, how they progress through their careers. So make sure that you support people if they want to do this data science, support them in what they're doing and consider that for their career development. Embrace if somebody's coming from university with programming skills, just embrace that. Don't shove the spreadsheet in front of them. Make sure that they can actually utilize their skills to the full potential, and we can have a collaboration within that Venn diagram where we learn from each other. Embrace division of labor. I think some people like managing data. They enjoy it, get them to do it, because then it empowers the rest of the project to work with that great data set that's going to be underpinning the decision making that comes from that. Have good data management as part of project delivery. I often find we focus on that report that's being issued to the client, but actually the data is as important as the actual decision that you're basing on that data set. So share that with your client, give them a good data set. If you can, support clients in sharing data openly. So I've got the Dig to Share initiative in there. Share code if you can on got an image of GitHub. There's other ways to do so, and support staff training. And yeah, the little quote actually links to what Holger was talking about, and that is ensuring that there are clauses in contracts. If you work on government-funded projects, make sure that the data are shared with the BGS, but it doesn't have to be just government clients. There's a lot of different companies that have to undertake grant investigation. So if you can support your client in sharing the data, that'd be great. Education research. I quickly looked at what is in the Geological Society accreditation for universities, and I found that quote of the theme 5 of the Geoscience Toolkit. You can see that it mentions some digital and GIS skills, but I suggest that universities go beyond the accreditation requirements. And if you can't have specialist modules on programming or data science, at least include data-driven way of working as part of the degree, i.e. make sure that the students learn to store data in a database. They use code to analyze the data, mapping in GIS and so on. I understand that it's beneficial sometimes to do stuff on paper for learning outcomes, but then they need to have the skills to then apply data science to their job. So yeah, and collaborate with the industry. And that's not only on research topics, but also making sure that the graduates that come out of that university have got the skills that are then really important to the industry. And then last but not least, we've got government bodies, regulators, and cross-industry organizations. We'd love if the regulator said, you have to say it, you have to share your data openly. I think that'd be a great world where we could share all the grant investigation or any other the data that we've got and sharing code. It'd be great if the digital infrastructure also improved. I found it interesting when she said I had to click on each project one by one. I mean, yeah, it always puzzles me the fact that every council has got their own planning system that's managed differently. I'd love a overall planning system somehow perhaps linked to the BGS with the data for the grant investigation. Data standardization. If we had data that's more standardized, it'd be then easier to collate and work with that data. Because due to lack of standardization, we often have got even clients that have got large assets, but because the grant investigation was done in different parts, we can't collate it. And encourage data science skills. So that's starting with programming for GCSEs, then going onto university, but also as part of chartership. I'm not actually aware yet of a professional body around geoscience that has got the data science skills in the curriculum, and actually you might more likely to hear people of being more kind of penalized for doing stuff digitally rather than on paper. We've got a very quick case study. We both worked on a great project for a client who required us to work differently, and the individuals were empowered to come up with new ways of working. You don't need to read the details, by the way, on the slide. That's just an image to illustrate what we were doing with the data. We were managing the data really well. We had a geospatial common data environment. We had a database for our grant investigation. The individuals were empowered to suggest different ways of working. And because we managed the data well, we could have automated data processing, automated data transfer between different databases, automated reporting, sharing the data between the different disciplines. So we had the geoscientists sharing the data and information with environmental specialists, with engineers, designers, and it really helped to deliver that project. So we've got an article in the GE magazine, and we were also shortlisted for a couple of awards. So this is just an example showing how we went with the land contamination assessment with generic potential sources of contamination, and then we did some scoping of which ones we want to assess and which one we don't. That's the result following desk study, and then result recorded following the grant investigation. And that's everything from us. If you want to contact us.
Great presentation. And I empower you all to leave this room to listen to these types of individuals and to say, if I don't understand what you've done, because it's not been in my career path to have understood the outcome of working in this way, how can you teach me? How can I collaborate with you, and how can I understand? Because I know for a fact, on a very similar trajectory from you guys, sometimes change stopped because the person I was working up to said, I just can't understand how you've done it. And that's a fear, isn't it? So let's take some great questions, if we could, for Emma and for Petra. Should we start in the room? There's a few in the room, got two hands up, one at the back and one at the front. There we are. We'll come to you in the front, I promise, straight after.
Hi, Petra. I'm Rhiannon from Gateshead Council. I think you made a really good point about the fact that digital geoscience within courses, it's usually people are penalised for it rather than being able to do things digitally. But obviously, it's becoming more and more ingrained in the industry as a whole, whatever you go into. Do you have any ideas, and I know there's obviously a lot of discussion across the industry and us all, what we can really do, I guess, to work with universities to get that within the courses where it's like that it's becoming essential at this point?
Yeah, this is one of the things I'm trying to do actually as part of my job. I've actually engaged with the Geological Society, with the people who look after the accreditation, and I'm due to give them some more information and look into that in a bit more detail. I think, yeah, it's working with the bodies that do work with the accreditation. I think that's definitely part of the step. And then I believe sometimes in change just one person at a time. So engage with one university at a time, and it's going to take a while, but hopefully it can spread because you influence one person and they influence one or two, and hopefully that can spread. But I'm sure there's other ways of doing that as well.
I think there are some.
Another question.
Oh, I think if you want to add anything.
Oh, well, we'll get in it.
Sorry, I was going to say there are. I think there are some universities that have programming in the curriculum, but it's just far and few between. I think. Yeah, so I think that'll students will talk with the feet, I suppose.
Should we take the question at the front?
Hi, Niall Tomlinson, SRK Exploration. A lot of what you said here, I work in mineral exploration, and what you said here transfers completely to mineral exploration as well. I noticed in your Venn diagram, you had domain knowledge, statistics, programming, and sort of that sweet spot in the middle. Unfortunately, not a lot of people occupy that sweet spot. So do you see opportunities or a future where we work more with maybe data scientists who would have no background in geoscience, but maybe other spatial data sciences, and don't have the domain knowledge and working in collaborative teams? Or do you think it's always going to be a case that it's some of the domain knowledge branching out into those other areas?
I think there is definitely potential for working with somebody who is specialized in data science and has got really like hardcore programming skills. But I think it's beneficial, at least if you've got some like small amount of data science skills, because then you know what's possible. So you might not want to do the programming yourself, but you will be able to know what is possible and what isn't. So as I said, I've just done a simple Python course, but there's people who are a lot better programmers than I am. But I'm now sitting at an edge of actually being able to talk to the people who are going to do the programming and knowing what's kind of partially possible. So I'm hoping that answers the question. I think having some skills, it doesn't have to be great, massive data science skills, but at least some, so you know what's possible, what you can ask that person to do, what you can't, how do you communicate. I think it helps in general. And then they will learn about geoscience as they're analyzing the data.
A question.
Got one more in the room?
Is this working? Yeah. So Callum Irving, Forestry England. So it was really nice to see a mention of data standards and schemas. So thank you for mentioning that. One of the questions I've always asked myself, and it's more of a kind of what do you think about this, is are we at risk of not seeing the wood through the trees? In the sense of we're living in a world now. When I first started, we didn't have much data. Now we've got loads of data. We've got so much data that if you threw every analyst in the room at it, they'd sit there squirreling away for hours, probably months, years. The question really is, do we need to get better at information and intelligence communication rather than simply collecting data for data's sake?
So I would say that from our perspective in our industry, we collect the data because we're trying to answer a question. So that already kind of helps with knowing what we're trying to do with the data that we're working with. So I think personal opinion is you always go to the data, you'd be asking a question and trying to figure something out. And then that's the reason why you're analyzing it. I don't know if you've got anything else to add, Emma.
Yeah, I think that was kind of, yeah, we've got a lot of data, absolutely tons. And it's like you said, is it, if you're not going to do anything with it, what's the point of it? But some data is being passively collected anyway. Some of it's there to be, like Petra said, that we're going to go out. I think it's the key is trying to not waste time and resources and money trying to duplicate what's already there. I think that's the key, is the management of what we've already got. I mean, how many times have you, well, from our point of view, done a GI where down the street there's already been a GI, but that data has been lost because someone's left the company or somebody's left. But it's kind of just capturing that and making sure it's properly utilized.
Should we go online, because we must remember those not in the room? Steph, have you got a question for the microphone?
Yeah, no, I've got one. Thomas Perriman of Fortescue Future Industries. How can we best build thinking differently into contracts? Many contractors are reluctant to engage in performance or outcome-based contracts.
Good question. I mean, I guess you go with you'd go through a tender and you'd have different contractors pitching for the same thing, and you can engage with them in what you actually want as a client from them, and I'd choose the one that's giving me what I want. And I think that's something I'm trying to push for anyway as part of my job, is to go with a lab that gives me the AGS data in the format that I want. So I think I try to select them based on what they're already promising to do. But I guess then there's that kind of question, are they actually delivering it? We might later on get into sharing the data via blockchain. That might be an option for the future. So you'd have tokens based on when people deliver the data or not.
I'd also say as well, like Petra said, from when we went through the future outlook bit, if who, like your power of influence, if the client or the government organization or whoever your client is, if they're putting that, if they're requiring that, then you've kind of got to do it. So that's a key one, is like, who are the drivers? Is it a client or government organization or some other kind of body? That's kind of key as well.
Perfect. Thank you. Tom, I know you're in Australia, and I encourage you to read the UK's construction playbook, which talks widely around contracting and kind of principles of openness. Project 13 in the construction sector is a fantastic